square root of 18, and so on. And so we'd be shifting phase. So here's a phase of 3 pi over 4 and an amplitude of root 2. And so on and so on and so on. So basically each of these points can be expressed by a phase shift and an amplitude. And as a result, constellations of this kind, when they're in passband, using the basis vectors I described a second ago, these are extremely common in practical systems, and they're called by a variety of names. One is quadrature phase and amplitude shift cube. And the phase and amplitude has to do with the fact that each of these points can be expressed with a phase shift, like a rotation, a signal space, and a scaling of that vector. But basically, this is what it means. So, in practical systems, you can have enormous constellations. You can extend this idea out to, it's usually a power of 2, like I've said before, those are the easiest to deal with because they map easiest into binary. I've heard of 128-point constellations, things of that nature. Okay, any questions on that? So, another thing we can do with, and I should just point out, whenever you have one of these, all you have to do, take our basis vectors, revert it back into the signal space analysis that we did, finishing up with 2 classes ago, and everything's the same. So basically, by translating it back into signal space, we already have the tools to deal with that. So another thing you can do in the passband is you can do